Hello, this is simply about networking protocols, and today I tell you about OSPF Neighbors, Hello protocol, and election of designated and backup routers in the LAN. Standard that is used to prepare this video is the same RC2328. We're still talking about OSPF version 2. In this video I tell you some tips of OSPF areas topology. What are neighbors, OSPF neighbors, and hello protocol, hello initiation, hello communication conditions, and election of designated router and backup designated router per LAN in OSPF area. The main tip for OSPF areas topology is that area boundary cannot be in network or link. So this topology is incorrect. Area boundary should cross router, actual router, our device. Schematically, it can be displayed like this. So some some routing interfaces of our router depends to one area, some router interfaces depends to another area. Specification claims that for each area, separate OSPF instance copy should run on this device. And in case this device is a bounded device for multiple areas, then it means that several routing interfaces depends to one area, several to second area, several to third area, and several to fourth area, and for each area running its separate OSPF instance copy. Okay, so but let's imagine that our router is starting inside some area, but it just starting. It has no information about itself yet. It has no information about area yet, about boundaries, neighbors, routes, and so on and so forth. So our device is wake up and investigates itself, applies all configuration detailed and destined to this router only. It means that this device needs to load till it understands all the routing interfaces, cost for those routing interfaces, paths, ports initiated, but this is at the beginning, and so on and so forth. Then this device knows everything about itself, but doesn't know anything about neighboring situation. And it starts discovering neighboring situation, sending hello, OSPF hello packets through every routing interface, including virtual link. That means OSPF virtual link. For any reason, topology can be wrong, because information wasn't full, because some link was misconnected, because administrator was thinking about different things, whatever. So anyways, our device, our router sends hello packets to every routing interface that connects to this device, to this one that is virtual link as well, to this one, to this one, to this one, doesn't matter what. And it will receive hello packets through every routing interface, on other end of which place it another OSPF aware router that sends hello packets. But in case of connection to router R7, the situation will be pretty simple. Hello packets from R7 will be dropped on our device, because this router doesn't belong to the same area. If there would be two areas and interface where that is connected to R7 would be in the same area with this R7, then hello exchange packets will be successful and correct, but in our case our device is internal device for the area 1 that is blue, so exchange to any device that is not in area 1 will be blocked. Those packets will be dropped, and those packets will be dropped on the beginning because every OSPF packet contains area ID field. On the receiving of OSPF packet, system checks is area ID in the packet same that interface belongs to, and if not, this packet is dropped, ignored, and not participating in the further processing. What about neighbors? For hello packet, that is OSPF packet type 1, all neighbor information should be added to the packets that device exchanged with neighbors actually. So hello packets have information about all neighbors of this device to inform neighbors that they are treated as neighbors. Okay. And how it works in general. In our router R1, we're generating hello packets. Hello protocol or OSPF hello protocol is not actually 100% dialog protocol. It's periodical protocol. So hello packets being generated every some period of time. So we are generating hello packets towards our neighbor R3. R3 generates its own hello packets towards our R1. They verify information in received packets, and once they agreed that they're receiving packets from each other, they are neighbor devices, and then verifying information inside those hello packets to see are they adjust. If they adjust, they agree that they are adjust, and now they can exchange all information using OSPF protocol eventually, building topology information, and so on and so forth. How it looks in packet. In packet that is generated from R1 to R3, R1 identifies itself, saying that this is from R1, identifies area, OSPF area it belongs to, well, filling in all the control information that is required and so on and so forth. But right now, since this is first hello packet, R1 doesn't know about any neighbors, so none is written in the neighbors area, neighbors field. On R3, this packet will be verified for correctness of the packet itself, that IP packet is correct, and then it will be verified for correctness of hello packet. So are those neighbors? Are they in the same area? Are they in the same network? And do they have same hello interval, router data interval, and options? To be adjust neighbors, they should have this information matching. If R3 agrees that R1 is a neighbor and can be adjusted, at some following hello packets, it starts adding R1 into neighbor information for this network. So at some point, R3 will send to R1 packets where it identifies itself, claims that belongs to the same area, and claims that it recognizes R1 as a neighbor for this network. Then it's fine. If both routers recognize themselves as neighbors and neighbor information is correct and adjust, they are adjacency agreed, and they start, or they are ready to exchange all following OSPF information according to the OSPF protocol that will be discussed in following videos. Okay? Neighbors can be within area only. This is the main condition. within area 1. So router R7 stands alone and not recognized as a neighbor. What a pity. And now to designated and backup routers in OSPF. The main goal of the designated router in the LAN is to reduce control information that is running through the LAN, help to build topology faster, and react to topology changes faster and more correct. Keyword here is a LAN, local area network. Designated and backup designated routers are elected not per area but per LAN. And in case we have situation where two routers are connected directly, P2P, they should not or could not or will not elect designated and backup, so it can be disabled, because this is the only devices in this network connecting them, and in case something happens to one of them, this communication is broken. So designated and backup has no sense. Only in LAN that has multiple routers connected to it, it is necessary to react to problems or topology changes related to one of the routers, so other routers connected to the same network could react correctly and quickly, ideally in zero time. So elections are per local area network, and elections happens in the following way. In every hello packet we have a router ID, router prio, designated and backup information. Those four fields are important to elect designated and backup device correctly. And elections happens in the following way. On the first stage, backup is being selected. And in selection of backup or election of backup, participating only those devices that do not declare themselves as designated, no matter whether they elected as designated or not. So for all devices that do not try to treat themselves as designated, we are verifying are they claiming themselves as backup. If one device, only one device, declared itself as backup, well, everybody agree, it is selected as backup. Perfect. If two and more devices declare themselves as backup, or none has declared as backup, then between all the declared or all the devices except those who are trying to be designated, selected one backup, one with highest router prio, or if there are multiple devices with highest router prio, one with highest router ID. That's simple. On the next stage, for all devices who are not backup, so backup device not participating in selection of designated. For all devices that are not backup, if one has declared itself as designated, agree, one is designated. If two and more declared as designated or none declared as designated, again, one with highest prio, or if several have highest prio, one with highest router ID. Then for each LAN we have designated and backup designated that are for LAN only and not taking into consideration other LANs and connections. And our devices in the area are ready to actually exchange OSPF information. That's simple. Thank you. Have a great day.